Assalamualaikum and hi to all my students. This video lecture is about type of logical connectives. Okay, as you can see here, there are 5 types of logical connectives. Okay, the first type is negations, the second type is conjunction, and the third type is disjunction. Fourth type is implication, or the other name is conditional. And the last type, the fifth type, is conditional. Okay, let's go first. Let's go to the first type of logical connective, that is negation. Okay, the first type is negation. So negation, negate, we read it as not P, or opposite of P. So the symbol for not P and opposite of P denote as not P, this or this symbol, not P. So P here is a propositional variables that we use, for example, right? So the truth table for negations is, okay, P, just single proposition, P. Okay, so the number of possible rows here is given by 2 to the power of n. N is a number of propositional variable. Alright. Okay, so here propositional variable is 1. So 2 power of 1 equal to 2. So the truth table for the negation consists of 2 rows. Okay. So the value for 2 rows is either true or false. Right? So the proposition not P is opposite of P, gonna be false and true. Okay, so that is a truth table for negation. Alright, next let's move on to second type of logical connectives, which is conjunction. Okay, conjunction 2. Conjunction. Okay, so we read conjunction as a P and Q. So we have 2 propositions here. So we denote by symbol P and Q. Okay. So the truth table for this conjunction is, okay, construct a table PQ. Okay, so how many possible rows? Okay, so 2 power of 2 propositional variables, so equal to 4. So 4 rows gonna be here. So 4 rows is true, 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 false, false, true, and last one is false, false. And the proportional P and Q, okay, note that the propositions is true only when both is true. Okay. So only when both is true, so this proposition is true. The others is false. Right? So this is the conjunction truth table. Alright. So let's move on to the next type of logical connective, which is disjunction. Okay, disjunction, okay, I read it here to compare. Easiest comparison. Okay, so 3 here is is disjunction. Let's look if you can see it. Alright. Disjunctions, we read it as P or Q. Also involve two proposition here. Okay, so P or Q denote by symbol P or Q. Okay, so the truth table for these propositions is okay, sorry. Okay, why? Right. What happened to my pen? Why is it like this? Okay, sorry for the plan. Okay, P and Q. Okay, the truth table, true, 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 false, false, true, and last one is false, false. So the proposition here, P or Q is false. Okay, P and Q is false here, false. So the proposition gonna be false. So the others is true. Okay, so we compare here. Conjunctions, we have one true, that is when P true and Q true. So the others is false. This is conjunction. While disjunction or P or Q is false only when P false, Q false. So the others is true. Alright? Okay, so let's move on to the next type of logical connective, which is implication. Okay, for implication, I make it next. Okay. Okay, so the fourth type. Sorry, I said it third, right? Okay, the fourth type of logical connective is implication. So implication, okay, not this slide yet. So this slide. Okay. So implication, we read it as if P, then Q. So this P is a hypothesis and this Q is a conclusion. Right? So if P happens and then Q happens. Okay, so implications denote by symbol P implies Q. Okay, P implies Q. Alright. Okay, so what's the truth table? So we construct a table. So P, Q. P implies Q. Alright, so 2 power of 2 is 4. So true, 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 false, false, true, and false, false. Right, so bear in mind that the proposition is true only when both P and Q is true. Okay, so both P and Q is true is here. Both P and Q is true and also P P is false. So the hypothesis must be false here. Okay, and both is true. So the proposition is true and true and true. So the others is false. Alright, so that is the truth table for implication. Okay, look here. The implications, on the other hand, can also be read as, okay, if P then Q. P is sufficient for Q, Q if P, so conclusion happened if P happened, Q when P necessary condition for P, and so on. So you have to familiar because the question might ask you other than usual name that we use here, if P then Q. Alright. Okay, next, from implication, we can form a related implication. So if we, alright, and if we converse this implication, alright, okay, if we converse this implication, okay, so the new implication gonna be Q implies P. So if we contra positive the implication, we will get not Q implies not P. And if we inverse the implication, have not P and not Q, right? So if we do the truth, if we construct a truth table for these implications, we can find the contrapositive implications have the same truth value as P implies Q. So here is equivalent to this. Alright? Okay. Then we move on to the last types of logical connective, which is by conditional. Okay, number 5. 5 is by conditional. Okay, so by conditional we read it as P if and only if Q. Okay, P if and only if Q denoted by this symbol. Alright, so P if and only if Q. So how does truth table for this one? Okay, we have P, Q, and biconditional propositions. We have two power of 2 here for, so true, 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 false, false, true, and false, false. Right? So the propositions is true when both P and Q have same value. So same value, the proposition is true. So the others is false. Right? So here is the truth table for biconditional, and here is truth table for conditional or implication. Okay, and biconditional also have another terms like implication. So the another terms for P, if and only if Q is, if P then Q, and conversely P is necessary and sufficient condition for Q. So this also you have to familiar with. Alright. Alright, so this is the example for by using another terms of conditional, and there are some exercise that you have to do by your own. Okay, last one. We look at the precedence of logical connective. Alright. In 5 types of logical connective, they have their own parentheses. 1, 2, 3, 4, and 5. Their own precedence. So the first parity is not. Okay, so to construct a truth table letter, first thing first, you have to do negation. Okay, next, for second and third is either and or and. So for easier, you can do what's come first. Okay, so the fourth is implication or conditional, and then the last one, fifth, is by conditional. So this is the precedent for type of logical connective. Okay, so let's do exercise here. Okay, make a new drawing. Okay, let's draw a table. You have to construct a truth table of the compound proposition P and not Q implies not P or Q. Okay, so I show you example. So we do a table. So excuse my writing. You have to use your rulers. Okay. Okay. So we have two proportional variable P and Q. So we have 4 possible rows: true, 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 false, false, true, and false, false. Alright, so the first precedent is negate. So we negate P and also we negate Q. Right? Let's look if we can see or not. Alright, we try to. Okay, not P. Opposite of P gonna be false, false, true, true. Right? So negate of Q is false, true, false, true. Okay, so we're done with negation. So next is and or. Okay, so we do what's come first, P and not Q. P and not Q. Next we do for P, not P or Q, and then we do for implications here. Okay, so we do first for P and not Q. Alright, P and not Q, true, false is false. True, true is true, false, false is false, false, true is false. Alright, then we do for the next is not P or Q. Okay, not P or Q, true, false is true, false, 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 true, 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 and false, true is true. Okay, last one we do for implies. Implies here, implication, if both true and then P is false. P is hypothesis. Okay, so we look here, both is true, I think, and P, the hypothesis, is false. So we have here false, false, and false. So the truth table gonna be true, 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 and here is false. Alright? So done. This is the truth table for the compound proposition here. Okay? Alright. Okay, then let's look at next subtopic, which is logical equivalence. Okay, for logical equivalence, I might continue with another video. Okay, so see you soon.